So, hi, my name's Jim. I'm an associate professor at the leading Scandinavian technical university called KTH. And I'm going to talk today about, if this is working, I'll have to, okay, so I'm going to talk about a new distribution of Hadoop that we've developed over the last few years called Hops. And I'm going to talk, just to kick it off, we've been running this in production at a data center in northern Sweden, a place called Luleå, since April, roughly. So we have about 100 users of the platform right now. And it's become really a testing ground for the new research features we're adding into our Hadoop distribution. But what we're also doing is providing a service to researchers. So we have researchers from the areas such as climate science, genomics, biomedical data, and they really need resources to store large data sets. So we have data sets on the order of 40 terabytes in climate science, and then we have some quite large genomics data sets as well. So these people need somewhere to store it, and then they need to process it. So we're in a position that we're trying to get those people to move over to platforms like Spark. We do run a Hadoop platform, so it's running on Yarn. So we support everything from Spark to Flink, and we also support Kafka. And what we find is that people are, at least the scientists and researchers, they're choosing Spark primarily. We haven't seen any shift as of yet. So it's a 72-node cluster. It's running up there, but what is it running is the question. So what it's running is a new distribution of Hadoop called Hops. The file system is called HopsFS, and how it's different to Apache Hadoop is that we have a distributed metadata layer. So if you look here at this diagram we have here, you can see in the middle we have name nodes. So if you're familiar with HDFS, HDFS has a single Java virtual machine that manages all the metadata for your file system, so that all your metadata has to fit on the heap of a single JVM for that to run there. And what we've done is we've taken that metadata and we've pushed it into an open source in-memory distributed database. So it's a highly available database. It's free. It's GPL licensed. And what we can do now is that we can add name nodes to scale out our file system, and we can add database nodes as well to scale it out. And the level of scale we'll see quite soon is quite impressive, I think. So that was our original research goal. We were going to try and build a file system that had its metadata stored in a distributed in-memory database. And this is the first production system we're aware of that's doing this. This has been a hard problem to solve. And what we've done is we moved on from the file system. We said, OK, let's do it for Yarn as well. So Yarn has cluster state, and we moved it into, again, the same database. And what we saw in Yarn is that, OK, there's some nice benefits to this. We can take the cluster state and we can export it. One thing that I'll mention later on that we're doing with the exported state of the cluster is we're doing quotas. So we'll see later on that we have this abstraction called a project, and we can give users a CPU quota. So you can say to a user, you get 2,000 minutes of CPU time in Yarn. Go ahead and use it as you like. You can start 200 cores and run them for 5 minutes each, or you can run 1,000 cores for 1 minute each. So what our Yarn architecture looks like is that we have a scheduler node, which is making scheduling decisions. It's running out the capacity scheduler, FIFO scheduler. And then we have these things called resource trackers. So resource tracker is an internal module inside the resource manager in Yarn. And what we're doing is the node managers are now heartbeating to the resource trackers. So they're not heartbeating any longer to the scheduler. So we're able to offload that traffic to resource trackers. So we've done some benchmarking of this, and we find around 25,000 node clusters, this will continue to have quite high utilization levels. So utilization levels in the cluster will only drop after clusters larger than 25,000 nodes. And then there's HA, of course. If your scheduler fails, resource tracker will take over. The scheduler itself still handles the application requests from application masters. OK, so I mentioned that we have a database behind this, and it's a GPL licensed database. And obviously, Apache Hadoop is Apache v2 licensed. The way we solve that particular problem is that we've introduced an intermediate API, kind of like the JDBC API. And our connector to the database is a JDBC connector, because the database is JDBC. And that gets around the licensing issue. So if anybody's interested in doing this on their own favorite new SQL database, you can write a connector and see if you scale out. We haven't made any effort to do it on a different database yet, but because we find that the performance has been quite good. And here's the performance. So this is the file system, our HopsFS file system. And if we look at the bottom line down here, we can see this is the performance of Apache HDFS. So this particular benchmark was done with Spotify's current Hadoop workload. So Spotify have a 2,000 node Hadoop cluster, and they run a large mix of Spark, MapReduce applications. And we took that workload and we benchmarked it against HDFS, and we were quite impressed. We got 75,000 operations per second. Now, for our particular setup, if we took the same number of physical machines, it would be slightly off the diagram here. We were about 10% better. So with the minimum setup for HA name node would be 3 nodes, so 2 database nodes, and you can run a couple of name nodes on top of them. We're about 10% better. But what we can do is we can just scale out. So if we go up to 10 name nodes with 2 database nodes, that's this green line, you can see we're getting linear scale up at that particular level. Now the database becomes a slight bottleneck at that point, so the green, we get a nice fall off in terms of adding more name nodes. And we can see if we go from 2 to 4 database nodes, we can get up to 600,000 ops per second and so on. And if you're curious about the gap between the red and blue lines in the middle, well, that's because we have some scans in the workload. So it's quite a complex workload on the file system. And when you have scans and you have a larger cluster, that means the scans take longer to return. So scans will, but you can see we have scope for improvement here. So the kind of interesting point about this is that we've now hit a very interesting milestone in HDFS, over 1 million operations per second on an industrial workload. If you're interested in more about this, Oracle we had a press release with Oracle last week, and you can Google it and see a bit more details on it. Okay, so that's the Hadoop distribution we call Hops, and we've been working on this for a number of years. So we spent a lot of time thinking, okay, if my metadata is in a database, and I can now easily tweak it, I can easily change it, I can tinker with it. So the name node as it currently stands in the resource manager in Yarn and Apache, you can't tinker with them. They're extremely highly engineered products. It's very hard to extend them. But in our case, we can add tables to provide new features. So for example, we did erasure-coded replication, and it was quite easy. You just added some tables to manage the erasure-coded replication state. But what we thought about was something bigger, right? So we said, okay, are the abstractions or concepts that we have in Hadoop sufficient and necessary for people to do collaborative development on Hadoop? And the answer, of course, we came to is no. And what we wanted to do was introduce new abstractions that would solve some of the problems that we see out there. So one of the problems that we see right now is clusters. People are launching clusters because, for example, they have a sensitive data set. So I have a sensitive data set. I'd like you to work on it. I'd like to work on it myself. But if we work on an existing cluster, you can maybe copy the data somewhere else, and Hadoop has no protection against that. So even with Kerberos enabled, there's no support for dynamic roles in Hadoop, so it's very hard to allow people to work on projects where they can't move the data somewhere else where they can do some other processing with it. So we want to get rid of clusters. We said, okay, we'll introduce projects instead of clusters. And what we came up with the following model. It's a project-based multi-tenancy model. So what you have is the equivalent of GitHub. If you think GitHub, you can create a project. It's self-service above all else. So self-service means that users will be able to create projects. Users will be able to add other users into their projects, remove them. They'll be able to share data sets between projects. And you don't need a sysadmin to do this. So if you're familiar with the popular distributions of Apache Hadoop, you will know that there's products such as Sentry and Ranger, and these are quite complex products, and only sysadmins really handle this sharing of data between different users. And they're very complex products, and the threshold of learning how to use them is quite high. So we'll see here that the threshold here is very low. It just feels like you're using GitHub to create a project, and sharing a data set feels like Dropbox. You just right-click, share a data set, and you're done. So the project will contain a number of users. It will contain a number of data sets, and we also have support for multi-tenant Kafka. So since earlier this year, Kafka supports a security model based on either Kerberos or certificates, so X509 certificates, and we're using the X509 certificates route. But your topic is now isolated in your project. So if I have a project and I create data sets and topics, nobody outside the project can access them. And this is very important for people like biomedical researchers who want to make sure that in their study, nobody else can access the data. You can't even cross-link to some other data set or outside of the project. It's also in line with the upcoming GDPR regulation or law that will come into force in Europe next year. So our projects have users, data sets, Kafka topics. We have support for notebooks. They also have quotas in terms of storing the amount of data you have in HDFS, but also the amount of CPU you use in Yarn. So what we find actually interesting with users with their CPU in Yarn, we allow them to create 5 projects, and often they'll put the same data sets in the 5 projects because they run out of CPU in one project, then they go to the next project and use the CPU on that, and so on. So they get quite creative in using them, and we need to think about how to make them, allow them to use their quota better. Okay. So I mentioned that Hadoop doesn't support dynamic roles, but we do. So how do we do that? So you log in or authenticate as a single user, but when you want to actually run a job or maybe copy some data or add some metadata or search, you only do it within the context of a project. So we have a user here called Alice, and Alice is authenticated or logged into the web app. And when Alice wants to do some work in a project called users, Alice will run as the user, users __ Alice. And if Alice switches to another project called NSA, Alice will run as that user. So we have different users in the system. So HDFS sees these as 2 different users, and if Alice tried to copy data from the users project to the NSA project, HDFS would say, nope, you're different users who own these files. And the mechanism we use behind this is secure impersonation in Hadoop, and for Kafka, it's X509 certificates. So I thought I'd just mention a little bit X509 certificates because if you go back to the archives of the Hadoop mailing list, there was a long debate about using Kerberos or X509 certificates, or SSL certificates as they're called, and the decision was made to go with Kerberos. Netflix have built a whole new system just around X509 certificates for internal use, so we're kind of going at that model. So what that means is services like Spark, HDFS, Yarn, Kafka, they all have support for SSL. And the certificates they're given are signed by, we generate a certificate authority when you install it. So they're signed by a certificate authority, but for every user, what we do is we create a new user per project, and that user will get their own certificate. So when you add a user to a project, remove a user from a project, a certificate will get created or removed. And the certificates are stored in our database. The Hopsworks platform as a whole is clusterable. You can have many instances of it, so we're actually using an intermediate CA rather than a root CA there. So if I want to write a Spark streaming app, how can this help me? Well, I'll show you in a couple of slides the code, but I'll give you first the picture of what's happening underneath the surface. So Alice wants to launch a Spark streaming job, and I'll do a demo of this later. And what she does is first launch the job. Now, after she's launched the job, what we need to do is we need to use Kafka. It's a Spark streaming job. We assume you're using Kafka. So we need to get the certificate or private key for that particular Kafka topic. So within your project, you'll have your private key and your public certificate. But if you want to talk to the broker, you need to have your private key to talk to the broker to identify yourself. So we also need to find out where Kafka is running, and we also need to find out where the schema registry for Kafka is running. So once we know that data, we get it from the database, we launch the Yarn job. And the Yarn job will copy our jars to the node managers that are going to run. It'll obviously start up firstly the app master, and then in Spark's case, then they'll run the executors. And what we do is we copy the certificates or materialize the certificates with the help of Yarn as a private local resource. So it's only visible to that particular application, and when the application exits, it gets cleaned up, which is very nice. So when you write your application, what you want to do is you want to basically set up your connection to talk to Kafka, produce to Kafka, consume from Kafka. So we provide a utility called Kafka Util, which will do some of this work for you. It will read the certificate, it will get your schema from the schema registry, and it makes it easier for you to produce and consume to Kafka. So how Kafka does access control, when you talk to Kafka, we extract the username from the certificate, and we then go to the database and see if you're authenticated to execute the operation you want to execute on Kafka. So we have role-based access control for Kafka. So what this does is saves you a lot of work. So if you're going to write a normal Spark streaming application, what you'd have to do firstly is you'd have to firstly discover the endpoints for the schema registry, the Kafka broker. Maybe that's global data. What happens if it changes, particularly in a Yarn setup, if things are running on Yarn? They may change. Then you need to create your properties file, reference the certificates that you're using and details about the broker. You need to then download your schema from the schema registry, and you need to distribute your certificates out to all the hosts. And that's really kind of an operations issue more than a developer issue. And you need to do all this securely and clean up, of course, after yourself. So there's quite a lot of work to do, but we've managed to get it down to just a couple of lines of code. So once you know your topic name, you can call our Kafka util. It will give you back a Spark producer. And with the Spark producer for that topic, you can just produce straight off. You don't need to worry about all this details about how to get a reference to the Kafka endpoint, how to download your Avro schema, and so on. And it's the same for consumers. So for consumers, we can use our Kafka util to get a reference to a Spark consumer, and then we can basically consume from that Kafka topic. So that's Spark streaming, but the platform supports more than just launching streaming jobs. We support notebooks, we support Zeppelin. And in our experience with Zeppelin was quite interesting. So in April, when we did our first, I think, workshop, we had about 30 people using Zeppelin, and they all launched jobs at the same time, and we were running with the Spark interpreter. And they were quite good machines, 256 gigs of memory, but because this Spark driver runs locally on the same server as our web application server, it fell over, which was pretty embarrassing. So we knew we needed to do something about it, so what we said was we worked towards getting the Livy interpreter for Zeppelin up to production quality. So what Livy is a REST server to access Spark jobs or launch Spark jobs in Yarn. So you have a REST server, you make calls and say, please launch this application, this Spark job, and it will launch it and manage it for you. So no longer is the driver running on the same machine as a Zeppelin server. Another tool that we found extremely, we introduced in the summer, which has been extremely helpful to users, is DrElephant. I was at the Spark Lint talk earlier, which seems very similar, and that was Groupon who did that, but this is LinkedIn who've done it. And there's quite a few users for it now already, but what they do is they'll go to the resource manager in Yarn, they'll go to the Spark history server, and they'll acquire a lot of data about the jobs that have run. And then they have a set of pluggable heuristics, and they'll run the heuristics against your job history, and then you get some good feedback about whether jobs have used too much memory, what performance, what caused them to crash. Did you have a reduced by key that caused the driver to run out of memory, or whatever. So it's a really nice tool for helping users debug their projects. So for us, running the cluster, what we often have is people say, oh, can you please go in and look at my job? And we do that by them adding us to the project. We go in and have a look at it. But we found that this has helped quite a bit. OK, the last point before I do a demo, I'm going to say is that this is a Hadoop stack. Now, the thing about Hadoop stacks is they're quite intimidating to install them. And every component we have here has been chefified, for want of a better term. So there's automated installation of the platform. So if you want to test this out, if you have an EC2 account or Amazon Web Services account, or even a Google Cloud, or even just a bare metal machine, you can do it with the help of a web application called Caramel. So it's a standalone application to run the Chef code. It's an orchestrator for Chef. So I'll do a demo now. I have time, I think. So I'll start off by just showing you Caramel now that I've mentioned it. We'll escape this here. Let me see if I can.
Question?
Yep.
Does your stack integrate with standard logging solutions like either ELF or Spot?
So the question is, does our stack integrate with, sorry,
Elasticsearch.
We have Elasticsearch as part of the distribution, actually. So we do, so funnily enough, my screen, as is expected, it's not showing up here. So let me just see how I got this up.
There might be Elasticsearch deployed to the database distribution, but there might be Elasticsearch as part of operational infrastructure
So,
Like the question is if you already ship by all means configurations that collect specific logs of those old.
so what I can't demo today, but I see if I can get this up actually. Do you know how to? For some reason it's not showing. It seems that my screen is gone. So we first, there we got something there, did we? No. Okay, this is not expected. Mm-hmm. It's upside down. It's going to be quite hard for me. All right, here we go. Great, thank you. Okay, it's upside down. Okay. Ooh. Yeah, it's gone upside down. Oh, there we go. It's control Alt up.
Maybe I don't know why.
There seems to be a delay on it. Okay. Are we? Oh, we're good. Okay, I'll skip Caramel, considering time. Sort of, it seems to be bad. Oh, I won't actually. So you basically just load your cluster definition here. Is Amazon here, just to show you it's a three-click thing. Is the internet working here? No, I think it's okay. No, it's on Wi-Fi. Okay. Live demos. Okay, so Caramel's actually up here. So that was, I loaded the cluster definition, and you can configure these. Because it's Chef, it's actually going to go out to GitHub to look for all of the parameters for your different cookbooks. So you can actually go in and configure lots of different, if I pick Apache Hadoop here, you can go in and configure all of these different parameters before you set it up, which is really nice. And once you've configured it, you can actually save that and export it as a YAML file, and then you can import it again. So what it does is it takes your public-private key, it will copy that onto the VMs that are launched, and then it'll use Chef to install the software. So if you just press submit, that's it. If you give it now, I don't know, 20 minutes or so, it'll install the whole stack. So when it's installed, this is what you get. And this is a completely bare bones project. It started up. On the question of Elasticsearch, so we do integrate search of the entire file system. We export the entire file system to Elasticsearch, so that's part of the thing here. I'll just quickly run a tour so that you can see how a tour works. So we have a tour for Spark here. Oh, that one's there. We go. You got a bug going on there. So I'll skip the Spark tour on that one. We'll log in here. Okay. Let's try the Spark tour here. See if it works. So when you come in here, you can see on the right-hand side we have projects. I just clicked on the Spark tour there. I'll go in and have a look at the Spark tour to get started. So the Spark tour, if we follow it, it'll just launch a job for us. So I'm just going to click next, next, and you can see it's giving a job name, and then it's going to ask for an actual jar file for the job. And we saw Flink there, by the way, if you're interested. We run Flink as well there. And then we can create the job and run it. Okay. So this is just one of the Spark examples that will run. I mentioned earlier we have a quota, so the moment the cluster is lowly loaded, this is just a VM, and the price is 1x, kind of like Uber, right? So when the load gets higher on the cluster, the price will go up. So that job is now running. What we can see is that we have members of the project. If I go down here, I can add new people to the project. It's pretty straightforward. So we go and pick one here. I can add this person here. And I can give them a role as a data scientist or a data owner. So a data scientist cannot upload or download data to the project. Only the data owner can do that. So that's the way we handle sensitive data sets. So I can add someone as a researcher to a project and know that they won't be able to copy the data in or out. Now, we don't prevent screen scraping, so if you want to screen scrape, you can do that. Oh, okay, we see the job ran. It was just a pie job. It ran like there. We can see there's output for it. And if we look around, we can see the logs for that pie job were printed out in here into this Spark project. and you can look at your logs. We're using log aggregation in Yarn to do that. What we can also see is that the history server, this is our DrElephant application. We can look at the details, and the job completed okay, and we can look at the heuristics results, and it'll tell us, there was no particular problems there. So that's a really nice feature. Okay, so that's, I'll jump ahead now and look at the Spark streaming example. So the question related to Elastic, I guess, is how do you get the logs? If we're using Yarn, how do you get the logs from your Spark streaming applications and view them in real time? I was hoping to do a demo with Elasticsearch, Kibana, and Logstash, but we just didn't get it together on time. It's not, because we want to have it as one of these microservices here, so that's our plan in the next month, is to get that one out. But what I'll do is I'll just show you a job that we're going to launch, which is a producer that's going to write a Spark streaming application that will write to, a Spark application that will write to Kafka as a producer, and another one that will read from Kafka as a consumer. So how do you create a topic in Kafka to begin with? It's quite easy. So firstly, you can add new Avro schemas here. You can just put one in there. I can add an empty one here, for example. That's a valid Avro schema, in case you're interested. Schema name should be empty, though. We'll call it empty. And we can validate it. OK, so it's a valid schema. So that's all you have to do. That's a schema registry we have. The actual topics you can just create by clicking on New Topic, and we can call this Spark Summit. And then I can pick a schema for it. So we're enforcing it. We're kind of doing the same as Confluent in that we're enforcing an Avro schema on topics. So that's a new topic. So once I've created, that's how trivial it is to create a topic. And that topic is now local to this project. So if I go into another project, well, let's go out here to our consumers. Here's another project called Consumer. And if we look in Kafka, we only see one particular topic in here called Gautier topic. Now, what I can do is I can share that topic with the other project by basically just clicking on this link here. And I can pick a project to share it with. I'll share it with this one. And that's it, right? That's how simple it is. So we can have isolated projects, which are completely isolated with one another, but they can communicate through shared Kafka topics, and we can also share data sets between them. So sharing a data set will just look as easy as the following. If I pick one out here, we'll take this one that I generated earlier. So if I right-click on that, I can just go share data set. We can also make them public for anyone, and I can put it in the Gautier Consumer project. And then if we go back to the Gautier Consumer project, we can see that the data set will be there. Now, Gautier Consumer project never asked for that data set, so before they get it, they click on it and they're asked, will you accept it or not? So it's unsolicited. It's very easy to upload and download data here. So let's say I remove that README. Let's add a new README here. And it's very quick, right? So I'm in a shared data set. So that's very nice. It shows security property of it. I wasn't allowed write to that particular data set, so it said you're not allowed to do that. So I'll just change this README here. A different data set. Because everything is in memory, HDFS is extremely fast, as you'll notice in here. Okay, so that's uploading a file. It's not a big file, and it was a README. So for the actual data sets that we have here, you can write Markdown for them to visualize them, so they can give nice descriptions of them. We have metadata. You can attach arbitrary metadata, and the metadata will be consistent because it's just a pointer to the inode, and we use foreign keys in the database to ensure the consistency of it. So if I run quickly, I might have time to run the Spark streaming example. Let's do it quickly. I'm running out of time. So running this job is just run here. So I'm going to run it. And that's launching the Spark producer. It's writing to Kafka. Yarn has a slow startup time, so it's going to take 20 seconds for that to kick off. And you can, if you want, you can look in Yarn to see it kicking off. I'm just going to go straight to the consumer and start the consumer. I could, let's see if we have time. I'll just write a new one. That's my name there. So this is just to show you how you do it. You basically have to pick out your jar file, which is this one, the HopsSpark one. We put in the name. And this is a consumer. So it's going to pass two parameters, consumer, and then the folder in HDFS, which is Gautier consumer. And then I'm just going to create it. I'm actually going to give the name of the Kafka topic here as well. Okay, so that's basically defining a job. But I also need to add our util, our Kafka util library. I forgot about that. So that's our library which we're going to use to do all the secure aspects of launching, reading and writing to Kafka. So that's the job I defined. If I run it, you can see the price has gone up because the cluster is a bit more loaded. And what this will do is it'll write the output to this particular streaming job. The producer is just writing some random data to the topic, and then the consumer is going to write the output to HDFS. So we can see that when it comes in here to the output directory. Okay, so this is it here actually at the top, or at the bottom. It's running. Okay, so it should start producing data any second. The logs will come in here at the end. So you can have a look at them. They'll be aggregated into Yarn. But while it's running, like I said, in future, we're going to, this one, the output directory. Yeah, this is our new one that came out here. You can see it, 5.11, that's it. So we can then preview that if we want to, and we can see it writing out. So there it is, it's writing out all the data there. Okay, that was a demo. So if this works, I can go back. It does. Let's go to the end. So what I talked about was our new Hadoop distribution, Hops. We support Spark as a service. I didn't have time to go into Zeppelin, but we have support for batch jobs, streaming jobs, secure Kafka. It's security first, and we can see that it makes it a lot easier to write Spark streaming applications. A lot of people have worked on this, so I'm just one of many. And if you want to find out more about us, you can go to our website, hops.io. And if you have any questions, I'd be happy to try and answer. Thank you.
Hi. We've got time for just one or two quick questions. If anyone wants to ask Jim a question. Any questions? Okay, see anyone, Jim? Okay, great. Thank you.